Hello, welcome to Flip. So today we're on acids and bases, and now we'll be talking about the reactions and properties of acid. Okay, so in our previous video, we mentioned that there are two kinds of acid, strong and weak acid. Am I right? So strong acid is complete dissociation, whereas weak acid is partial dissociation. Okay, so we'll be using strong acid as an example in the reactions because it is when the H plus is dissolved to its greatest extent, okay? And so that's why it can be used in reactions. And please take note that in order to have acid reactions, H plus has to be produced. So if H plus is not produced, the acid itself has no reaction at all. Okay, first we will start off with the acid with metal giving us salt and hydrogen. How this works is quite simple. So we have a magnesium here and a chloride here. So they both will come to form magnesium chloride, and the two remaining hydrogens atoms becomes the hydrogen gas. Okay, that's quite easy, right? Next one is similar in the sense that magnesium and chlorine forms magnesium chloride here. Then the two H atoms and one O atom will form H2O. Remaining CO3 here, okay, will form the CO2 gas. Okay, this is already just memory work. Next one is acid plus metal oxide giving us salt and water. Also, acid plus metal hydroxide giving us salt and water. So let's do the oxide one first. Okay, so we have magnesium and chloride giving us magnesium chloride, same thing, and the two atoms of hydrogen with one atom of oxygen, okay, giving us water. Okay, super simple. Next one is a bit special. Okay, the mechanism is the same thing. Sorry. So Mg and HCl, Mg and Cl will form MgCl, magnesium chloride. H and OH will form two molecules of water. This one, please take note, is called neutralisation. Okay, neutralisation really just means when, okay, H plus OH minus, okay, to give us H2O. This H2O is neutral, okay, as with water, right? So it's neutral. It's because the positive charge has neutralized the negative charge. So it's a neutral charge right here. Okay, remember this process is called neutralisation. Only happens when the H plus reacts with a OH minus hydroxide ion. Okay, so this is the three processes that you have to remember, okay, for acid. Okay, next we'll move on to the properties of acid. First one I want to touch on the litmus paper and universal indicator. Okay, when in contact with acid, okay, you will form red. How I like to remember is that acid is always red, whereas alkali, you will learn later in the next video, is blue. Okay, so with this you will never go wrong. Acid red, alkali blue. Okay, quite simple. Okay, next one, acid conducts electricity in aqueous solution. That's because in the case of, for example, HCl, okay, it forms this, right? In our previous video, we talked about this. So HCl will break into H plus and Cl minus. And all these individual ions now become charge carriers. Okay? What do I mean by charge carriers? Means that they can hold on to charge themselves, the electricity charge, okay, and bring it from point A to point B. Okay, so that's what it means to be a charge carrier, and hence is able to conduct electricity. Okay, next is acid is corrosive in nature. Okay, this one just means that you should always wear gloves when handling acid, because when you do not, okay, and it touches your hands or any body parts, it will actually corrode and maybe eat into your flesh or your bones. Okay, so it's very dangerous. So please take note. Okay, this is dangerous. Okay, next one is that it's sour. Okay, sour in the sense of lemon. Okay, actually lemon, if you didn't know, Okay, this is my lemon. Lemon contains this acid called citric acid, okay, which we talked about in the previous video. Okay, and this gives its distinct sour taste. Okay, so all acids are sour. Finally, the use of sulfuric acid. Okay, this is just memory work. Okay, as in the learning objectives. Sulfuric acid only has 3 purposes. Okay, it's a component of detergent, fertilizer. It's also used as a battery acid. Okay, so you can see that these 3 are very distinct, functions, but sulfuric acid plays a part in all of them. Okay, so next video we'll talk about alkali.